Larson Davis just launched their new dosimeter, the Spartan 730. So what we're going to be talking about today will be focused on that device. The Spartan was designed with our customers in mind, and when it was discussed to add an accelerometer into the meter and what the benefits would be, everyone agreed there'd be a huge return of value for that feature. So we're going to focus on motion in noise dosimetry. So I'm Danielle Smith. I've been at LD for 3 years now. I started as a technical writer, working in research and development with the engineers and designers, and I was writing all of their manuals and making procedural videos. And you can see a lot of those on our website and on YouTube, so check out our channel. I transitioned to a customer-facing role this January. Otherwise, I would have written the manual for the 730 dosimeter. Now I help our customers with their project planning and scope and supporting in the field. You are welcome to email me with any questions, or if you need any help in your next acoustic-related project, I'll be able to assist. So here is what we are doing today with our topic in motion in dosimetry. First, I want to introduce the Spartan to those of you who are not familiar. And I'm going to talk about the reasoning behind putting a motion detection in a noise analyzer. And then I'm going to bring in an engineer here at Larson Davis to talk about the mechanics and testing of the accelerometer. And finally, we'll go over your data and what it will look like with motion detection. Lastly, like I said, I'm going to unmute everyone, and you can ask any of the questions that you have. All right. So the Spartan 730 noise dosimeter. The personal noise dosimeters are a cornerstone of any industrial hygienist or ergonomic consultant's arsenal. The new LD meter was designed with that customer in mind. We've gone cable-free, and we have a rugged, durable, easy-to-use device. The Spartan can all be operated in just one hand, and the entire meter clips onto the shoulder of the worker. No more cabling from the mic to the belt pack to the shoulder. This dosimeter is actually truly wireless in more than the mic cable. There is also no need for a charging cable. The lithium battery inside can be charged on a Qi charging pad. You can see the photo there. Also, with the Bluetooth low-energy signal that's in the device, downloading your data happens right when you get into range of your computer with our software, G4LD Utility, or within range of our mobile phone app called Atlas, which is available right now on the Apple App Store and the Google Play Store. All right, so the last and great feature that we put on the Spartan is the accelerometer. But why do you think that is? When we wanted to improve the design on a personal noise dosimeter, we gathered a list of headaches from industrial hygienists and other professionals in the field, and we noticed that there was a problem that no one has solved. How do you know if your data was taken accurately? How do you know after you clipped it onto the shoulder of the worker and walked away until the afternoon that they kept it there? We noticed that there was a speculation among people that perhaps the worker, once the coast was clear, simply unclipped the meter, laid it on the table or near the device. Maybe they didn't like wearing it, or they didn't feel comfortable with a microphone on them all day. Whatever the reasoning, the data needs to show what truly happened in that work shift. And if your meter has detected no motion in 15 minutes, you're actually going to get an alert, causing you to go investigate on the floor what is happening to the meter. So who benefits from knowing the orientation and motion of your noise dosimeter? You. So there are actually two main reasons to need an accelerometer: knowing if your meter is moving and not moving, so you know if someone's laid it on a table for the day, and then also bump detection. It is actually common to be looking through your data and see a sudden spike in the middle of it, and how can you explain it? Did the machine the worker was on suddenly let out this explosive noise, like 85, 95 decibels right by the worker's ear? This is serious information and should be dealt with. Or did the worker just forget the dosimeter was on his shoulder and threw a wrench on it accidentally, or whatever the case is? Bump detection is easy to distinguish from a noise exceedance with the Spartan, and the Spartan is actually smart enough to decide it is a bump noise and not a noise that's going to truly affect your data, and automatically exclude that bump from your data set. So Larson Davis, as you might be aware, is a division of PCB Piezotronics, which is a sensor company. When it comes to motion and noise, we have history and performance standards behind us. So I wanted to bring in Alex Blodgett, an engineer who was the lead on the team who researched and designed the Spartan 730 dosimeter. He has great insight into the engineering and designing of what went into this project. How are you doing today, Alex?
Doing pretty well.
So do you want to tell the people in the webinar a little bit about yourself and your history at LD?
So I'm a computer engineer. I've been working here at Larson Davis for about 5 years. Started out doing hardware design, moved into some of the firmware design. I do a little bit of both now, as well as helping with some of our software development and developing the Atlas app, actually. So I really enjoy solving problems, and working with products like this allows me to solve lots of problems.
That's great. All right, so my first question is, what were the technical challenges of adding an accelerometer to a dosimeter?
So with accelerometers, there's a wide range of, you've got the high precision accelerometers that are going to be very useful with lots of precision, but they may pull a lot of power. And one of the big challenges for this dosimeter is we wanted one that's going to fit on your shoulder and is small, but allow us to run for a long time, 40+ hours of battery life.
Right.
And so we really needed something that was going to be small enough that we could fit in to our dosimeter and still be able to give us the data to meet the needs that we see for our customers of knowing whether there's motion or bumps. And so really trying to limit, and so we can have something with low power but still give us all of the data that we need in the accelerometer is kind of the biggest challenge, and then integrating that in to all the other measurements we have with the noise and keeping track of it over the measurement and showing it in our data in the software.
Right. So how did that work out with finding something low-powered and small and lightweight?
It worked really well. We were able to find a nice small accelerometer that gives us low power, that gives us 3 axes of motion, and is able to give us all the data that we need for this application. It could even do even more, but we're able to focus on what our users are going to need this for.
None of the data we don't need, everything we do, right?
Correct.
All right, so tell me, what kind of blue sky ideas did you and your team have about an accelerometer in the dosimeter?
Well, so initially we were like, this would be lots of different things you could do. We could have it where if I pull up the app, you can see how the orientation of the device is on someone's shoulder in kind of a 3D view. We talked about we could make it be a pedometer to track someone's steps if they wanted to wear it for the day, to make sure they get their 10,000 steps in, or maybe just the orientation to see, hey, is someone bent over during their work shift, and able to give that data. Really, we kind of pared most of that back to say, really, what the core thing is, what Danielle's already talked about, that making sure they're doing their work and it's not sitting on a table somewhere, and also that bump detection to be able to, if there's some loud noise due to that bump, we can show that in the data, but they can exclude that data automatically.
Oh, that's great. All right, so yeah, that was my next question, which is, what did you decide would be needed for this application? Like, what would the Spartan and the customers truly need?
And a lot of this came from, as we were able to talk with users or other people who are industrial hygienists that have had experience with this, that are wanting to know, if I put this on a worker's shoulder and they're out on the work floor all day, are they really wearing it for the day? Can I make sure the data I've taken is going to be good, so when at the end of the day when I'm saying I'm compliant to whatever regulation I have, I can guarantee that worker was wearing that and moving around like they should have been for their work shift.
Right, which I think is truly like the Larson Davis way, which is we are going to give you accurate data that you can guarantee is correct, and it's always going to be correct. All right, so we're going to look through some of your testing. So I got these graphs from you earlier, and this is part of your testing process. Do you want to walk me through what's going on here?
Okay, so we have 3 graphs here that's plotting some of the data that we get off of our the accelerometer to allow us to see the data here. These 3 ones are 3 different scenarios that we have with the data. I'm going to talk first on the y-axis is giving us in milli-g, the acceleration. It's just measuring mostly the acceleration due to gravity or other motion that we have. And you can see on our graph on the far right that says no motion, this is the dosimeter is just sitting on a desk over time. And you can see there's just kind of a flat line for all 3 axes that we have, x, y, and z, with one of the axes is almost exact, right around 1,000 milli-G, which is 1 G, or gravity, and it's sitting there flat on the desk.
So gravity's pushing down.
So gravity's pulling down on it. That's the acceleration that the accelerometer measures. If you look on the graph on the left, this one is, the orientation's different, so you can see that the relative average for each of those lines is different, because this is one worn on the shoulder. As I'm walking around, as I'm taking steps, it was making those big jumps that we're seeing. We're able to detect that with our software and say, hey, this is motion that someone's moving versus not moving at all within some range on the no motion. And able to detect that as I'm walking around and turning and moving, I'm able to see those differences within the acceleration data off of the sensor. The middle graph shows us a little bit more where there's some motion. I was picking up the dosimeter and moving it in my hand, and then I really bumped it with my other hand. And you can see the two bumps that I put in there that are a lot bigger spikes of acceleration. So we're able to see that in our data and say this was a bump versus just normal motion, and detect that and flag that so that our data can see, hey, there was a bump, not just motion here, and potentially needs to be excluded in the data rather than included for our final measurements.
That's great. All right, I'm going to move on to the next slide. This is actually a screenshot of the graph that appears in G4LD Utility, which is our free-to-download app or software program for PCs. And this graph will also appear in your app as well, the Spartan app. And so when you get your dosimeter and you make your data and you look at your graphs, this is what you're going to see. So talk to me a little bit about what's happening down here.
So this graph kind of plots over time our noise levels, but what we've highlighted down here actually gives us whether there was motion that detected within a given second or not. The green being a motion was detected, and then the no motion, we actually only highlight when there's a certain amount of time that there's not motion. If someone's not moving for a minute or two, it's probably okay, they're standing doing something normal. If it's a longer period of time, we default it to 15 minutes. I think on this graph was set to a 5-minute threshold. It then can flag it to say, oh, there was a period of time here that might not be valid for the measurement. I may need to go exclude this data after the fact to give me a better picture of what's going on.
So would we see a pink bar like that if somebody was maybe just sitting at their desk doing some data entry?
Probably unlikely with that unless they're asleep at their desk. Usually people, when they're sitting, from what we've tested, are still moving enough that over a 15-minute period, they're going to have enough motion that something gets detected for the 1 second. Someone could potentially be holding still enough if they were asleep to have that happen. But really, if it's set down on the desk or someone set it aside, that's really when you're going to see that no motion period for a long period of time.
Very good. So this is actually data that I took while I was traveling around Houston visiting customers last week. And so you can kind of see when I had set it down, when I wasn't talking about it, when I was wearing it, when I took it off. And there's a portion here. Actually, we'll talk about that in a second. I actually pulled up the time history to show that you can tell here, if you look through here on the motion section, that there are smaller periods of time that have no motion detected, right? And these appear, like Alex said, even though we didn't have the full 15 minutes and it didn't get flagged. So you can kind of see where I set it down or I put it in my bag or I was holding still and that there was no motion detected. And you as the industrial hygienist can decide is that valid data or not based off of what you know your workers should be doing for that day. So here we're going to talk about, I zoomed in on the graph. This is the part I was mentioning before. So when I pulled up my data, it already had this bin here excluded. Tell me a little bit about why that happened.
Okay, so underneath this exclusion band, there's a little tiny orange thing there for when there was a bump. So as part of this measurement, there was a bump that was detected, and as part of our software, when it has that bump, it goes in and tries to automatically put an exclusion band in the data. These exclusion bands allow us to come in and say, this data probably shouldn't be included in the measurement. Let's make sure and try to take it out. It does not take that data out of the measurement file. It then gives us a modified dose measurement to say, if I didn't have that data included, what dose would I have or other metrics that I need to have for my measurement.
Right, so in this case, I could see that my bump didn't actually affect my values here, my decibel values, and so I might go in there and just remove that exclusion because it didn't seem to affect my data either way. Is that maybe a good practice for that?
Yes, and we're able, with these exclusion bands, you are able to go in and delete them out and edit them. You could expand it if you needed to say, I need to exclude more because there was more affected than what was automatically detected, because it is trying to do the peak detection, but people do a better job of making sure the data looks more valid.
Right, and I think that's a great choice because instead of it being a relationship between the bump and the noise, it's just looking at your motion, your bump in the accelerometer and saying, hey, I think something odd happened here. You might want to double check what's happening. So here's kind of our contact information. There's our website. There's a phone number you can call to ask questions and get in touch with the right people. All right, you guys, thanks so much for joining us for this webinar. I highly encourage you to go visit our YouTube channel. You'll see the first video in this webinar done by Ken Cox, our product manager. Our next video in the series is on the sound recording feature, and that one's done by Carol Case, who is really great at these, so you'll highly enjoy it. So please just go sign up for it now so you don't miss out on it. And everyone have a wonderful day.